Okay, I think we can start. So, um, so my name is Lentin Joseph. I'm a ROSE consultant. I'm running a company called Qbotics. We are mainly doing ROSE-based robotic software consulting, and also we are providing education, robotics education, mainly using ROSE framework. So, and we have a blog called Robo Academy. So in this webinar, I'm mainly planning to introduce a robotic software framework called ROSE. So maybe some of you have already worked with ROSE. Maybe some of you maybe don't heard about ROSE, but this is just a basic webinar. And the ROSE is it will take at least 1 week to learn something on ROSE. So it's a big topic. But I will say this is just a head start to learn ROSE. So at the end of this webinar, I can share you some free ROSE books and also some courses from YouTube so that you can start learning ROSE. Okay. Okay, fine. So myself, Lentin Joseph, I used to write books also in ROSE. I have written about 8 books. So these are the titles. It's all books are related to ROSE. Learning robotics using Python, mastering ROSE for robotics programming, ROSE robotics project. Yeah, these are the books. And I also used to review books in robotics. So these are some of my books. Yeah, and these are some of the books that I reviewed. And regarding my experience, I started working in robotics from 2010 from my engineering from the engineering project itself. So after that, I worked for a robotics company called Asimo Robotics. I think you may have seen some news nowadays, like regarding a robot called Kami robot for COVID patients. So I work in that company, and in 2014 I started Qbotics Labs. It's mainly a robotics consulting firm, and after that I work 6 months with CMU for a research project. Yeah, and this is my blog called Robo Academy. It's mainly for sharing robotics tutorials, news, etc. This webinar will be based on my book called Robot Operating System for Absolute Beginners. It's designed for like people who don't have any idea about ROSE. So this is the agenda for today's webinar. So I will start with robotics, some basic concepts. Then we will see what is robot programming. Then we will start with ROSE. Then the future scope and job opportunities. What will you get if you learn ROSE? Then you will see some architecture working of ROSE. Then you can see some demos and simulation. Those are some advanced concepts, but you can see those things are included in ROSE. Then in the end, I think I can send you the ROSE book, a free ROSE book, and some YouTube video tutorial, so that you can start learning ROSE. Okay. Okay. So just watch this video. I think you can all see this video now. So how many of you have seen this kind of robot? I think it's very common. It's called line follower robot. It's the purpose of this robot is it just follow the line using some sensor, right? Yeah. So I will say this is one of the basic robot that we can make, a line follower robot. What about this robot? I think some of you have already watched this video. It's a robot from a company called Boston Dynamics in the US. It's a humanoid robot, and I think it's backflipping, right? Yeah. So it's doing backflipping. I will say this robot is very complicated, very complex. but we are calling this thing as a robot too. So we have seen a basic robot as well as a complicated robot. So I have shown that video for comparing the basic robot and complicated robot. What are the functional units of that of each robot? If you take the basic and complex robot, the basic blocks are the same. So what are the basic blocks? The basic blocks are the three main blocks. The first is sense. I think someone's mic is on. Can you mute? Okay, now it's fine. Okay, so the three blocks are sense, think, and act. Okay, so what is sense? It's sensors. So a robot will have a lot of sensors. In a line follower robot, it may be an IR sensor for detecting the line. In the Boston Dynamics robot, it may be some camera, inertial measurement unit, or some other sensors. So that is about the sense unit. And what about think? Think means it's a computing unit. This is in this unit, the robot is actually taking decision based on the sensor inputs. Okay, so it's our computer actually. So there are different types of computer. There are mini PC, microcontroller. Then there are a lot of types of computers. So that is the think section. And what about actuators? The actuators is simply the motors. So these actuators are executing the motion of the robot. For example, in the case of line follower, is two motors. That is the act part. That is moving the robot. Okay. So the think unit will take the decision whether it is a line or not, and the sense unit will sense the okay. So I'm just explaining again because my mic was on mute. Okay. So in this example, I was just demonstrating an example of that to understand the sense, think, act loop of a robot. So this is basically an obstacle avoidance robot. So in an obstacle avoidance robot, the purpose of the robot is to avoid obstacle. Okay. So to detect obstacle, there will be some sensors. It may be an ultrasonic sensor or some other sensors. Okay. So that sensor is a sense section of the robot. Okay. So that sensor is connected to the think section. It can be a microcontroller or a computer or any computing unit. So the think section will read the sensor value and it will take the decision, like whether is there an obstacle in front or not. So if there is an obstacle, then it will move backward. And if there is no obstacle, then it will just move forward. Okay. So I'm just explaining this example for understanding the sense, think, act loop of a robot. Okay. Fine. So I think I have already explained this block diagram. It's a detailed inside view of a robot. So if you check the act section, it consists of several actuators, and in the sense section there are a set of sensors. It may be camera, it may be a mic, it may be an ultrasonic sensor, whatever. And in the computing unit there are several computing modules. It can be a microcontroller. Microcontroller is a microcomputer, and in PC there are maybe mini PC or a laptop, anything. So this is the inside view of a robot. I think this is clear to you. Okay, so I'm just moving to the next slide. So these are some examples for sensors, actuators, and computers. For sensors, there are cameras, wheel encoders, ultrasonic sensors. So these are the examples of sensors. Then actuators, there are DC motors, servo, stepper, etc. So those belongs to actuators. And in the computer, we have Raspberry Pi. I think some of you have heard about Raspberry Pi. And Intel NUC, it's a mini computer, mini PC. Then NVIDIA TX2. So those are computing modules. And also the microcontrollers are also like the Arduino board. It's very famous. I think you already heard about it. It's a microcontroller board. So those boards can be used as a think section of the robot. Okay, fine. These are some of the basic concepts. So I'm just demonstrating some of the actuators here. Servo, stepper, gear. Okay, and these are some computing modules. There is Raspberry Pi. Then another single board computers. A single board computer means a computer in a small form factor. So the Raspberry Pi and Android is single board computer, and in the middle you can see the Intel NUC. It's a mini PC. So these computing unit can be used in robots. And these are some sensors. Here, these are some 3D depth sensors. Then these are some simple sensors like temperature sensor, humidity sensors, then some GPS. So the list continues. So I explained the block diagram of robot for explaining the robot programming. So we have seen sense, think, and act section. So which block is more important? I will say all blocks are important. For example, in an obstacle avoidance robot, if the sensor is not working, then it will be non-functional. Okay. And motors are also important. The computing unit are also important. But who is deciding the behavior of the robot? I will say the think section. So think section is taking the decision, like whether is there any obstacle or not, if the robot is in a line or not. So we are focusing on to that think section. Think means inside the think module there are computers. Okay. So the robot programming is simply, it's just the programming of robots. Mainly, if we are programming the robots using these computers, right? We can use a microcontroller, we can use a Raspberry Pi, Arduino, anything. So in a definition, if we can say robot programming in a definition, we can say like modeling the behavior of a robot. We have a set of programming languages like C, C++, Python, etc. So we are actually model the behavior of this robot using a programming language. That is actually a robot programming. So in a line follower robot, the programming will be in a microcontroller. Okay, so using some embedded C or Arduino, you can program it. You can program the behavior of the robot. In a complicated robot like the Boston Dynamics robot, we may have multiple PC or workstation inside the robot. Okay, so the things section in robot programming, what happening is that we are modeling the behavior of the robot, and the input of the model will be the sensor values, and the output will be the control signal to the robot actuators. So we can program the robot in many languages, embedded C, then we can use C++, Python, etc. So according to the computing unit, this programming language will vary. So you have seen what is a robot programming, okay? So how can we program robots? You have seen robot programming, and how can we program a robot? It's simple again. Either we can start developing a program from scratch. From scratch means from the zeroth position. Like if we are programming a robot, we are writing the code from scratch, from the start. Otherwise, the second method is we can use an existing framework to program a robot. Clear? So there's two approaches. One is starting from scratch or use some existing frameworks, right? So we can see the advantages of starting from scratch and starting from existing framework. Okay, so imagine you are creating a robot for you are creating a robot programming for a robot program for a complicated robot. For example, okay, an autonomous food delivery robot. So that will deliver food from position A to B. Okay. So if you are programming that kind of robot, and if you are writing the code from scratch, it will take lot of time. It will take lot of time. So that the writing from scratch is a time-consuming task. But for a long run, like if you are developing a product or something, writing from scratch will be better because you will have full control on your code. Okay, so that is the first method. I mean, I mentioned it's the second, but that is the first method that I'm saying, that it's a writing from scratch. So you can use any programming language, C, C++, Python, Arduino, any programming language for programming robot. The second method is programming a robot using existing software frameworks. That means there is a framework already. Okay, we can just use that framework and use the capabilities of that framework, and do some customization and deploy it to a robot. Okay, so that looks easy, right? Like it is a better approach for quicker prototyping. You can do it faster. Okay, so the advantage is we can do it faster, and it's good for academic research and all, because in academic research what happening is that we are focusing into one topic. So if you are focusing into robot manipulation, inverse kinematics or something, we don't need to bother about other things. We only need to bother about that specific thing. So we can reuse the existing thing, and we can fine tune the IK, inverse kinematics or something. Okay, so this approach is for the research and quick prototyping. Okay, so for example, for the existing software framework, one of the example is robot operating system. Using ROS is an existing software framework for robots. We can use this framework and we can customize it, and you can deploy it. So the robot programming cycle will be faster. Okay. Also the Arduino framework, Arduino framework, right? Arduino is again a high-level programming framework for programming microcontrollers. Otherwise, you have to do it in embedded C. Embedded C is little tougher. So these are the existing framework. Okay, so I think you got an idea about two approaches of programming a robot. So what we are focusing into is the existing software framework. We are using ROS. Okay, so now we can see some of the free robotics software framework available. One is ROS. It's actually for the main purpose of ROS is communication, inter-process communication. I will get into that. Then another famous library is OpenCV, open source computer vision library. It is for computer vision. I think you may be aware of computer vision. It's for image processing and all. It's an open source library. Then the PCL, point cloud. So point cloud is the 3D image kind of thing. So we can use point cloud library for working with PCL. Then there are some simulators available. Then some other robot framework available. So using these framework, we can make the robot development easier. Okay, fine. So these are some of the popular robot programming languages. First is C++, then Python, Java, C#, MATLAB. Okay. Okay, fine. So we are going to learn about programming robots using existing framework. So in this webinar, we are focusing on to ROS. Okay. So what are the prerequisites to learn ROS? Okay, so that is the important thing. So if you are planning to learn ROS, what are the things that you already know? Okay, so the first thing is learning Linux, mainly the commands, Linux terminal commands. Okay, so if you are aware of Linux terminal commands, and especially the Ubuntu OS, working with Ubuntu, that will help you. Okay, that is one of the prerequisites to learn ROS. Other prerequisites are understanding of C++ and Python. Okay, so if you have these skills, then you can start with ROS. Otherwise, you will struggle because you need these skills to learn ROS. Fine. So okay, so I'm just skipping these slides because it may confuse you, but I can say an abstract of this slide. Okay, so we have uh, talked about the three section of the robot: sense, think, and act. So in a complicated robot, the robot that we have seen with the Boston Dynamics, we can say it is a complicated robot. Those robots need a PC because there are a lot of computation happening. Okay, so in order to work with a PC, there will be an operating system. Okay, so in most of the robot, they are using Linux operating system, mainly Ubuntu. Okay, and there are some real-time operating system also, but in research and all, they are mainly using Ubuntu. Okay, so mainly in a if you are planning to work with a complicated robot, then you need a PC with installed with an operating system. But if you are working with a simple robot like a line follow or obstacle avoidance or something, you just need a microcontroller. And if you have an Arduino board or something, you can just program it. So you don't need an operating system. Okay, but if you are planning to build complex robot, then we need a PC, right? Fine. So these are some of the operating system used in robots. Uh, Mainly Linux variants, Ubuntu, Debian, then also like QNX real-time operating system in time-critical task and all. The researchers are using QNX and VxWorks. So some computational unit because we are going to install the OS to these computational units. This is Intel NUC, then Raspberry Pi, NVIDIA TX2, Odroid, etc. So, okay, so we understood that, we understood that ROS is an existing software framework for robots, programming robots. And we understood that we need an OS, operating system, for complicated robots, complex robots. So what is ROS actually? Is it an OS or something? It stands for robot operating system, right? But is it a real operating system, or we have some confusion, right? So before that, I can show you an example. Okay, we can start with an example. So this is one of the project that I did in my engineering bachelor's. It's an social robot. It's called a social robot. What it does is it will interact with people. It is having machine vision capabilities. It will detect people. Then it will show emotion. It will speak in English. If you talk to like a Google assistant. So I done this robot in 2010, I think. So at that time, Google Assistant, that technology was not very popular. So it is having speech recognition, image processing, etc., etc. So I have used two laptops. One laptop for speech recognition and AI things, and one laptop for image processing and all. Okay, so that is running on Ubuntu, and I just network these laptops and connected to this robot. And robot is powering using a microcontroller. These there are a lot of servos and all. There are 12 RC servos. So for controlling these motors and all, there are Arduino-like microcontroller. I think you may have heard about 80 mega microcontrollers. So I have converted. I have created a new Arduino board, custom Arduino board. Using 80 megabyte. So this was one of the project, and I can show you some of the challenges I faced during building this robot, mainly the software. So I mentioned that this robot is having two laptops. One is for speech recognition and one is for machine vision. And so there are a lot of processes, a lot of programs are running. one is for detecting, maybe one is for detecting faces, one is for speech detection, right? So maybe I think there are 10 programs simultaneously running for working, right? So the problem was I need to communicate from program A to B sometimes. Okay. For example, I need to send some data from the machine vision program to Arduino program. So for moving, imagine if you want to do the face tracking. Okay. So the machine vision program will sense the face. It will detect the face and send the centroid of the face to Arduino program. So Arduino will move the face of the robot too. So there are a lot of communication between programs are happening. So that is one challenge I faced. And it's very difficult to synchronize all these programs. Okay. It's very difficult. And also, the code was not modular. Like I use Python and C++, 10 code, I think 10 programs. So it's not modular at all. It's very difficult to reuse the code. If anyone plans to reuse the code, it's very difficult. So this is one of the architecture, or the communication architecture. There is a server client. It's a simple server client architecture. The server is the Arduino program. Arduino program means a Python code sending commands to the Arduino board. Okay. So if anyone want to move the robot, any program, like there is a computer vision program, speech processing, artificial intelligence, then it has to send to the TCP server. Then that will send to the Arduino serial. So that's how the working is. So there are a lot of communication between the program is happening. Okay. So after my project, I created a new project using ROSE. That is an autonomous mobile robot that I did in 2014 or something. So while doing this project, I used ROSE for working. So it's again like a complicated robot. This robot can able to deliver food, and it can move from A to B autonomously. Okay, so that is the purpose of this robot. So it is having some 3D depth sensor. Maybe you maybe heard about Kinect, and there is Intel NUC, and there are some microcontrollers. So I used ROSE, and I didn't face this issue with ROSE. Okay, so I'm just showing the differences. Like if we are using an existing robot framework, you may maybe the process may be simple. Okay, fine. So then the definition of ROSE. Maybe I can take the official website of ROSE. Maybe after discussing this. So ROSE stands for Robot Operating System. So is it a real OS? No, it's not a real OS. It's a meta operating system, meaning it's not the real OS, but it is having the features of a operating system. Okay, but it needs a host operating system to run, meaning it is working on the top of a host operating system, for example, Ubuntu. Okay, and the main core part of the ROSE framework is the middleware, communication middleware. Okay, so I'm just going to the ROSE website. Then we can explain. We can see the definition. Okay, just taking the rose.org. That is the official website of ROSE. So you can see getting started. There is install. Then about ROSE is there. So in the about ROSE, you can see the same equation. I have taken this equation from this. I taken this equation from this link. Okay, so this is official website, and you will get support also. A lot of tutorials. Tutorials are already there for installation. Okay, fine. I'm back to the slides. So rows consist of 4 parts actually. It's the first part is a plumbing, then tools, capabilities, and ecosystem. Okay, so we can see each blocks first. So what is plumbing? So I think this is the important part of rows, very important part of rows. Okay, this plumbing or communication middleware, using this middleware, 2 programs can easily communicate. I think I have explained the example project that I did in bachelor's. The main difficulty that I faced was communication between 2 programs or multiple programs. So ROS is having a middleware or some set of libraries or some function to communicate 2 programs, 2 or multiple programs. So if you see this block diagram, the oval shape is a program, or we can call it as a node. So this program is communicating to this program, and this is actually indicating it's sending some data. And this program is communicating to this. It is sending 4 kind of data. Got it? So this is an important part of ROS, inter-process communication or communication between multiple programs. For example, if you have a program named A, it can communicate it to B, then B can communicate it to C, like that. So it's basically a graph of programs that can communicate with each other, like this. It's we can call it as a computational graph. Okay, so you should understand this concept. Otherwise, you can't program in ROS. Okay, this is the important thing: communication, inter-process communication. Okay. So the next part is the tools. So tools are basically, just a second. Okay. Tools are basically for visualizing the robot data. Okay. So for example, if you have a camera, using tools, we can visualize the camera. I mean, the image from the camera. Then if you are getting some signals from some sensor, you can use these tools to visualize those sensor value. So in this example, if you can watch this screenshot, you can see a robot with some 3D data. So these are the laser scan. So in ROS tools, using ROS tools, we can visualize the robot models, sensor data, everything related to the visualization. Okay, so that is the ROS tools. Okay, then the third thing is the capabilities. This is again important. Like if you want to, for example, I have made that autonomous mobile robot, right? So I mentioned that there is a functionality in that robot. It can move from A to B autonomously. Okay, so actually to move from A to B autonomously, if you are writing the code from scratch, it will take a lot of time because it is very difficult. It's very difficult. It involves a lot of algorithms like dead reckoning, navigation, etc. So if you are using ROS, there is an existing programs available, existing packages, I will say. So we can just reuse it, customize it, and ready to go. Okay. So that is the advantage of using ROS. If you also, if you want to work with a robotic arm, then ROS is having packages to move the robotic arm, do the inverse kinematics. Inverse kinematics means if you move the robot end effector, then it will compute the joint angles. So there are a lot of capabilities in ROS that we can make use of. So we don't have to write these higher level things from scratch. We can just reuse it. Okay. So two of the important capabilities are like navigation stack. So using navigation stack, the robot can able to move A to B autonomously. And using move it packages in ROS, we can do the IK, inverse kinematics. Okay. Then there is a perception stack that is for image processing, that kind of functionalities. Then the fourth thing is the ecosystem. Ecosystem means ROS is an open source software framework, and it is having worldwide developers. So there is a community for ROS for maintaining the packages, creating the packages, and there is a ROS wiki for tutorials. If you want to work with ROS wiki will be very useful. And there is a Q&A platform, ROS Answers, for if you have any doubts regarding ROS, you can post it there. So these all things, websites are belong to the ecosystem. So I hope you got an idea about ROS blocks, the plumbing, the tools, capabilities, and ecosystem. Okay, so we can see details about it, details of each blocks. The first is the inter-process communication. I think you understand the concept, like there are 3 programs, and the program A can communicate to program 2, then the program 2 can communicate to program 3. In any ways it can communicate. So there is an operating system that is installed on the computer, and on the top of operating system, we are installing ROS. And using ROS and ROS functionality, we are creating 3 programs which can communicate with each other. So this is the fundamental concept of ROS, the inter-process communication. So this is an example. So the camera driver program is a ROS program which can read the camera images and send to another program called face detection program. Okay, so that face detection program will receive the image, and it will detect the face from the camera images, and it will send the Centroid to another program. So that program will receive the Centroid and send to some Arduino board or something. Okay, so this is how we are programming in ROS. Fine. Mainly the communication, inter-process communication. So these are the tools in ROS. There is RVs, RQT, and there are command line tools. RVs is a 3D visualizer. Maybe I can show you. So this tool that you are seeing is the RVs. You can visualize the robot data in 3D. Then RQT is more like a 2D visualization tool. It is having a lot of plugins. Then the ROS command line tools, as for debugging and all, it's very useful. So this is RVs and RQT. So in RQT, mainly we can plot. We can use it for plotting, debugging, etc. In RVs, we can visualize the 3D data like point cloud, PCL, then the robot model, etc. So the capabilities, regarding the capabilities, we have ROS navigation. It is for moving a robot from A to B autonomously. ROS move it is for robotic arm to move the robot arm, to perform the forward kinematics and invert kinematics. Also the perceptions. So this is some screenshot of ROS navigation and move it. So in navigation, you can see a map. Okay. So this green arrow is the B point, that is the destination. So the black point is the robot. So it will avoid this obstacle autonomously and reach this position. Okay. In move it, this is a robotic arm. and you have a control over the end effector, and you can just move the robot around. Okay, so this is manipulation. So this is an example for the rows manipulation. So it's basically taking a block, and it is stacking on the top of another block. So you can see RVs on the right side. You can see the robot model, and the robot is actually looking for the another block. Yeah, actually it's not stacked on the top of the block. It's just put it on the center. I think, yeah, this one will take on the top. So these capabilities, we can use ROS move it in order to perform these kind of operations. And another capabilities is the ROS perception. So in this video, what you are seeing is a mapping of a city. It's a 3D mapping. So there is a sensor called 3D LiDAR that is connected on a car. So when the car moves, we are actually we are taking that sensor data, and we are creating a 3D map. So these kind of capabilities are using in self-driving cars, autonomous driverless cars. So this is a 3D map of that city. So you can use ROS in order to work with these kind of functionalities. Okay. So regarding the ecosystem, there are a lot of developers from India. You can see the numbers. I think this count, I think I have taken 2018 or something. Now it's bigger. So these are the map of ROS developers. And we have ROS Wiki for getting tutorials, and answer.ros for posting our questions. So ROS is completely supported in Ubuntu Linux. Okay, so full support for Ubuntu and Debian, and it's experimental in OS X, and also ROS is fully supported in Ubuntu, and it is experimental in OS X and Windows. Okay, so I just want to discuss about the situation of robot programming before ROS and after ROS. So before ROS, what happened was there was no framework for programming robots. The researchers will use some custom code, and they will develop the code for their specific robot, and no one can use that code again. But after the research, that code will be useless. Okay, so there will not be any active community and all. Okay, that's what happened before ROS. But after that, after the ROS project, people started to create generic packages for their robot. So what happened was, if they started creating packages for their robot, it can be reused for some other robots too. That is the advantage of ROS, code reusability. So that's what happened after the ROS project. So as of now, we have I think more than 10,000 packages. I'm not sure about it, ROS packages. So we can just use this package for your purpose. You can customize it easily. Okay. So the code reuse is easy, and there is a common software platform for developing your robotic application. Okay, and we can even collaborate. For example, if there is a university in the US, they want to collaborate with an Indian university, that is possible using ROS, because if they are working with same version and all, they can share the code. Okay, so that will work. So that what happened after the ROS project. So who created ROS? These are some basic things. I can quickly go through it. So ROSE project actually started in Stanford. So initially the name was not ROSE. It was Switchyard. In 2007 it started. So the original author is Morgan Quigley. Okay. So after this project, this is Morgan Quigley, by the way. He actually did PhD under Andrew Ng. I think you maybe heard about Andrew Ng, the famous machine learning professor. So these guys are from Stanford, and Morgan started this project. And in 2008 to 2030, there is a company called Willow Garage. It's a research robotics company in US. So they actually taken this project and they named the project to ROSE. Okay, and they did a lot of development. They created, they created the core part of ROSE. Okay, so that happened in Willow Garage. So during the development, they also created robots called PR2 and Turtlebot. PR2 is personal robot. It's completely working using ROSE. And there is a robot called Turtlebot that is for educational purpose. So I will show you a demo of Turtlebot 3 at the end of the webinar, just a demo. Okay. And from 2013 to 2020, I will say, currently it is managed by Open Source Robotics Foundation or Open Robotics. So you can check the website for, this is a non-profit organization. They are mainly developing and managing ROSE, Gazebo. Yeah. So this is a Open Robotics team. Morgan is there. Then Brian is the CEO of Open Robotics. Then Tully Fute, yeah, Nathan. So these are the core team. Okay. So again, why we use ROSE? Okay, I think I have mentioned few points, but again, I'm quickly going through some of the points. Code reuse. Okay, so this is one factor that we are using ROSE. For example, if I want to develop a feature in my robot, what I have to do is just search in Google and check for ROSE packages. For example, face detection ROSE packages. If you search like this, you will get a ROSE package that is doing the face detection. So you can simply download it, do some simple customization, start ready to go. Okay, so code reuse is very important. Then the modularity. So in a software development process, modularity is one important thing, because if your code is not modular, it's very difficult to debug. So the code that we have writing using ROSE is modular. Okay, and obviously it's an open source project, and you can customize as you wish. Then you can use the ROSE in the process communication feature. So these are some of the important points that we are going to use ROSE, and you will also get community support. But moreover, you will get community support, and there are some you can do the computation. The computation of a robot using distributed computer. But moreover, the important thing is the job and research opportunities. So just a second, it's actually switching. Okay. Okay. So I'm just presenting in this way. Okay. One of the important reason why you have to learn ROSE is, if you are planning to do masters, for example, in robotics, and even in electrical or abroad, mainly in the US or something, you may need skills in ROSE. Okay, and if you are planning for a robotics opportunity, a job in robotics, I think most of the companies are now working with ROSE. So this skill is an essential skill in research and for getting jobs. Okay, so that's why we have to learn ROSE. Okay, a lot of companies are using it, a lot of research institutions and universities are using it. Okay, Now we can quickly go through the distribution. So what is a distribution? You may heard about Linux distribution. So what is a distribution? A distribution is a version set of programs. For example, if you heard about Ubuntu, there is Ubuntu 16.04, 16.10, then 18.04. There are different distributions or versions are there. Or there is Ubuntu, then there is Debian. So there are a lot of Linux distributions. So why we are creating these things and we are naming it as distribution? It is actually, if you take Ubuntu 16.04, it is having softwares which is having a specific version. Okay, specific version. For example, if we are using 16.04, you may get a software with version 1. Okay, but if you are using Ubuntu 18.04, the version may be 3. It may be an updated version. Okay, so that's why it's the versioned set of program. So in the case of ROS, there are distribution for ROS. So in each distribution, there are specific set of ROS programs. Okay. Okay. If you take ROS, for example, ROS Kinetic, we will get one version. If you take ROS Melodic, you will get another version. Okay. So it's similar to Linux distribution, and it's a version set of stacks, ROS programs. So these are some of the ROS distributions. In 2010, it's Box Turtle. You can see the letter after ROS. It was ROS Box. Now it is ROS C Turtle. So that letter is actually changing. In 2011, it's ROS Diamond Black. Then 2011 is ROS Electric. In 2012 is Furate. So Hydro. Then 2014 is ROS Indigo. 50 is ROS Jade. In 2016 is Kinetic. In 17 is ROS Luna Loggerhead. And currently it's ROS Melodic. Okay. So the latest version is Melodic. And in next month, there will be another release of ROS. It's a new version. And I think you maybe heard about LTS. I don't know how many of you heard about LTS, long-term support. So the Ubuntu that is compatible with an LTS Ubuntu, that is LTS Ubuntu is Ubuntu 18.04 is an LTS. LTS means they will provide you support for 5 years. So long-term support. Ubuntu 16.04 is LTS. 14.04 is LTS. 20.04 is an LTS. So the ROS distribution that can install on the LTS will be an LTS. LTS for ROS also. Okay, so this ROS Melodic can be installed on 18.04. So that is an LTS. Okay, that is because Ubuntu is giving the long-term support. So the ROS can also give the long-term support. The development is like that. Okay, so I'm just going through some of the robot that is supporting ROS. So after I think you are clear about the distributions. Okay, so latest is the Melodic. Okay, then some of the robots that is working using ROS. So the robot supporting ROS means it is the programming of the robot is done using ROS. Okay, maybe it may be a complete programming or say partial programming is done using ROS. Okay. So this is one robot that I have mentioned, PR2, that is developed by Willow Garage. Look at the specification of the robot. It is having quad-core Xeon processor, then 24 GB RAM, then 2 TB hard disk, etc. etc. It costs around 4 crore or something at that time, but it is having a lot of features, And this is the affordable one. So this is Turtlebot. It's a mobile robot, and it's mainly using for educational purpose. Then mainly what we can do with this robot is the navigation, autonomous navigation. Okay. So it's cost around 1 lakh or something, but we will get cheap platforms lesser than that, lesser than the cost of a Turtlebot. These are some other robots: Baxter, Pepper, Tiago. So these robots, and Robonaut 2 is a robot from NASA. Then FETS, TAL, OS. So these are some famous robots that is working using ROS. These are some mobile platforms supporting Pioneer 3DX, Husky. Okay. So we have seen the robot supporting using ROS. Okay. Now I think we can see some of the sensor that is supporting ROS. Okay. Sensor supporting ROS means this sensor is compatible with ROS programs. Okay. So these are some of the sensor. I think you may have seen that mapping of a city, 3D mapping, that can be done using Velodyne. Okay. Then the Kinect. Then these are all 3D sensors. Then these are some other 3D sensor. Even the camera is a sensor. Then the IMU. So these are some of the microcontroller board supported in ROS. Okay. Okay. So we have seen robots and sensors that is supporting ROS. Now we can see just the installation procedure of ROS. Just the installation procedure. I'm just going to the ROS website and the install. Okay. So if you go to the ROS website and the install, you can see the ROS distributions. There is Indigo, Kinetic Game, Luna, and the Melodic. So here's the latest Melodic and install. Okay, so you will get the procedure for installing Ubuntu. I mean, installing ROS on Ubuntu. So it's very simple only. Just copy paste these commands on your Linux terminal and the ROS can install. But make sure before running in your real system, I will prefer you to work on virtual machines. Virtual machines are software that you can install the operating system virtually. So like this. So I'm just switching on an Ubuntu 18.0 for OS. Okay. So it's just booting up. Okay, so if the advantage of using virtual machines are it will not create any problems. Like if you are a beginner and if you are starting with installing Linux on your real system, it may crash your hard disk or crash the PC. So better to work with a virtual machine software like VMware, VirtualBox, etc., and install Ubuntu on it, and you can install ROS on it. Okay, so just take this terminal and copy those commands to this terminal. So I think this in this PC, ROS is already installed. So it's already installed. Yeah, I just want to show you how to install the ROS. I mean, mainly the procedures. I think you can see the screen. Yeah, and how to install. If you are an absolute beginner, I will prefer to use a virtual machine. That is, if you just search for VirtualBox, you can see. So this is one of the virtual machine software. You can create virtual OS and VMware. So these are two virtual machine software that I'm preferring. So now we can see some of the demos using that is done using ROS. So in this demo, they're actually these demo was shoot in Willow Garage. So they're actually creating an application using ROS for fetching the beer from the refrigerator. Okay, so see, the robot is actually fetching the beer and taking, and it is supplying. So all these capabilities, all these things are done using ROS. Okay. Then in this demo, robot is playing the pool. See, it is automatically doing. So the algorithm is running on background, and this is actually always. And using some image processing and all, the robot can play pool. So the entire software is done using ROS. So these are some examples. I'm just showing the capabilities. Okay. Then some popcorn making video. So in this, robot is making popcorn. All the software is written using ROS. Okay. So I'm just quickly going through the videos because we don't have enough time. So this is another demo using the ROS navigation. See, the robot is navigating autonomously. It is creating a 3D map. It's avoiding the obstacles. It's creating the map. Okay. It's another demo. This is the Turtlebot demo. Currently, it is loaded with a follow me program, so it will follow a person. So currently, it is following the PR2 robot itself. Okay. Fine. So you got an understanding about ROS capabilities and what are the things that we can do with ROS. So this is another demo with the Turtlebot 3. So I will show you a simulation of Turtlebot 3 at the end of the webinar. So it's a small robot for research, mainly robotic research. Okay. So yeah, that's it. And along with ROS, you will get support for Gazebo. It's a robotic simulator. A robotic simulator is a software in which we can virtually simulate the functionality of the working of the robot. Functionality or working of the robot. Okay. So the advantage of the simulation software is before making the hardware, it will be better to create a simulation so that we will get to know the issues in the design, robot design. Okay, so that's why we are using the Gazebo. Then the Muthoot is for the manipulation, OpenCV is for computer vision, ROS Industrial is for ROS software for industrial robots, then the point cloud library. Then the important thing, which all other companies are using ROS? As of now, I think most of the electronics, robotics, computer vision companies are working with ROS. Okay, you can see Intel, ClearPath Robotics, Bosch, almost all the companies. They have a research unit, a research wing working with ROS. Even the companies like TCS, Wipro, they all have some research wing. Because I personally know, I know some engineers there, and also I invited to Wipro for some self-driving car project also. So these companies are working with ROS. Okay, so that's why it is important. More than a hobby, I will say you can make your hello. Can you see the screen? Just a second. Yeah. So more than a hobby, maybe you can convert your ROS knowledge to a job or a research opportunity or something. Okay, so mainly robotics researchers, students, professionals, hobbyists, and other vendors are working with ROS. And I mentioned about the jobs and research opportunities earlier. Even companies like NASA, then Tesla, Hyperloop, a lot of companies are working with ROS. Okay. Then what is the future scope? So that is an important thing. Why, if you are learning ROS, and what is the future of it? Okay, so what I'm saying is one of the important part of robot building is the software. So using software, we can create different applications. Then we can control the robot any way that we want. Okay, software is the one of the key aspect in any robot. So ROS is one of the popular software framework that is available now. It's open source and it's using by a lot of companies. Okay, so if you have an understanding of ROS, then you can create your own application from scratch itself, because there is a huge code base available from the ROS repositories itself. There's a huge code base. So a lot of opportunities are there. Then now it's becoming a standard in robot programming. Okay, a lot of people are using it. That's why. Okay. Then there is a conference in robotics, ROSCON also. I have attended the last conference. It's called ROSCON. That happened in Macau, China, in 2019. So in ROSCON, if you are planning to, if you are interested in ROS and if you want to learn more about ROS, then ROSCON will be a good opportunity, because you can see the developers, then the contributors, CEO of Open Robotics, everyone in ROSCON. Okay, and you can even present. Okay, and you can see the latest technologies and packages developed in ROS. So if you go to these links, then you can see the videos, ROSCON videos. It's again free. You can see the videos and you will get slides. Okay. Okay. So that is some basics about ROS. Now I am coming to the important aspect of this webinar. I'm not discussing the theory, much theory of ROS in this webinar, because it will take a lot of time. But I think I have mentioned about the inter-process communication in ROS, right? So I'm just showing you how the inter-process communication is happening in ROS. Okay. So what is the secret of inter-process communication in ROS? Okay. So this is a diagram that is showing the inter-process communication of ROS. So what happening is that there is a program called master in ROS. Okay, so I can show you. I'm just starting the master program. So if you enter a command called ROS core, we are literally starting the master program. Okay, so the master program is, I will say it's like a broker. Okay, so what this program does is that it helps other programs to find each other. For example, if program A want to send program program A want to send a data to program B, then this master program helps to find each other. Okay, so for starting the communication in ROS, the important program that we have to run initially is the ROS core. So if you run the ROS core, the master will start. Okay. Okay. Then in another terminal, we are starting a program. Okay. That is already available with the ROS packages. I'm just running. You don't need to worry about the commands and all. I'm just starting a program in ROS. Okay. The program name is Talker. Okay. So what Talker does is that it is sending a message called hello world. Okay, it's a string. Okay, okay, fine. Then I'm starting another program called listener. So it's printing I heard hello world, right? So it's basically both are communicating. Okay. So the message from talker is going to listener. Okay. So this is what happening. When we start the talker, it's contact to the master and it will say, I'm going to publish a data, string data, and I am sending this data through a bus. Okay, data bus. Okay, there is a name for the data bus. And when we start this listener node, okay, this listener node is also expecting some data from the same bus. That is a string message is expecting from the same data bus. So if that is the case, if both are sending and requesting the same message from a same data bus, master will allows master will exchange the information of one node to another. I mean, it will exchange the data of talker to listener. Okay. Then if the listener got the data information about talker, then both can communicate each other. Okay. Then after communicating, if they start communicating, there is no need of master. Okay. So that's what's happening here. Okay. I'm just closing the master here, but the communication is still goes on. Okay. But if I'm closing the talker, okay, and again start the talker, it will say fail to contact master. That means when we start communicating, we need master, and when it establishes the connection, we don't need master. Okay. So I'm just starting the row score. So now I'm just starting the listener also. So the communication started. So this is the, I will say, the hello world of rows. Okay, you have just covered the hello world of rows. Okay, there is a program called talker. Maybe we can call it as a program A, and it's sending to the program B, that is the listener. Okay, so you may be wonder like why what is the use of this example? Like it's simply communicating, right? Why how we can use this in a robot? So it's similar to hello world program in a language, right? Like before starting learning any programming language, we will just start with a hello world, right? Similar to that, this is a hello world program for rows. So just checking the communication capability of rows. Okay. So I mentioned these things are communicating each other. Let's see what's happening in the background. So this is the computational graph. The talker is the node, one node, and listener is another node. So talker is sending the data over a database called chatter. Okay, the name of the database is called chatter, and listener is expecting the same kind of data, that is string message, from chatter. Then master will allow the communication and it will talk to each other. Okay, this database name is called topic, and the message that is flowing through the database is called rows messages. Okay, so rows topic and rows message. I think you can learn more about topic and messages from the book that I am going to send, book and course, obviously. Now we can see another demo called turtle sim. So for learning rows, these rows teams actually given a small simulator called turtle sim. Just a second. So this is actually a 2D simulator. Okay, the main function of this or main purpose of this simulator is to learn rows. So you can use this simulator in order to understand the concept of rows. Maybe I can show you some example, like moving the robot. That turtle is actually a robot. So you can see the turtle is moving. So let's see what is happening in the background. So we can see the computational graph. See, the turtle sim is this. This is a program actually. Okay, so teleop turtle is another program. It is sending the velocity commands to this. Okay, that is happening in the background. Okay, so this is the inter-process communication happening. Okay, so we can move the robot around. Okay, fine. Okay, now we can see an advanced example. Okay, so I'm just showing these demos for understanding the inter-process communication, because we are running this process and you can see both are communicating and both are sending some values, some data. Okay, so that is important part here. Okay, now I'm just launching a simulator for turtle board. So this is a simulator called Gazebo. So in Gazebo, you can see the simulation. You can create simulation. And here is our small robot called Turtle Bot 3. Okay, it is having 2 wheels, and on the top of the robot there is a lidar. Okay, let's see how to move this robot. Okay, and we can also see the sensor data from this robot. So I mentioned on the top of the Turtlebot 3, there is a lidar. Lidar means it's a 3D range sensor. Just a second. So this is a ROS tool called Arvis. So in Arvis, you can visualize the data from the simulator. See. So this is a simulation, and in this simulation, there is a robot, and on the top of the robot there is a lidar sensor. It's a 3D rangefinder, and you are visualizing the lidar data in Arvis. So that is the importance of Arvis. Okay, you can also visualize the robot model here. See. Okay. Okay. So let's move the robot. So using the keyboard arrow, you see the robot is actually now moving. You can see in the simulation and in the visualization also. So what happens if it is hit the wall? See, there is a crash. Okay, okay, we can again hit it. Oh, just missed. Okay, fine. So I think it's clear, like you have seen the visualization simulation, and just see what are the which all are the programs running now, and which all are the programs communicating with each other. We are taking the visualization, the graph, computation graph. See, so there is a Gazebo, and there is a Turtle Teleop keyboard program that will send the velocity commands to Gazebo, and it is visualizing. So that is actually happening here. Okay, fine. So I'm just closing the thing. Fine. So so it's a time for wind up the webinar. So I will prefer you to refer some books of Rose. So these books are paid actually. If you want to learn the advanced concept, I think you can refer some of the books. If you want some free tutorials, I will send you a mail which is having some videos from YouTube and some free books to learn Rose. That book is good for beginners. So this book is for like absolute beginners. Like if you don't have any idea about ROS, then I think this you can prefer. And if you have some idea, then I think this video tutorial will work. Okay, and these are the contact details. I think maybe I'm actually writing a blog called Robo Academy. So you will get tutorial related to robotics, ROS, computer vision, etc. And if you want to connect with the social media, then you can go to the LinkedIn profile. Then this is my company website. So I'm mainly doing the consultation, mainly for the companies in US. And this is my mail ID.